Hi, this is Gansham. I'll be explaining our project on behalf of my team. So, we have been given a set of IPL data in the form of different databases like ball by ball, match, player match, season, team, and we have we were tasked to make queries on these and come up with some meaningful results. So, without any further ado, I'll get to explaining it. So each of these databases have some uh, relevant information. Like for example, this is a database called match, which holds the information of which teams are playing. For example, it's team 2 versus team 1 in season 1 of IPL held at Chinnaswamy Stadium, and the result is that team 1 won the match by 140 runs, and the man of the match was had a player ID of 2, and etc. Those kind of information that you do have in these databases. Another important one would be ball by ball. So this one holds all the information for each ball being thrown for every single match of every single season. So here you have information like match ID and which team is batting, which team is bowling, who is the batsman and who is the bowler, how many runs the batsman scored on each ball, be it 4, be it 0 or 6 or 1, and you also have information like extra runs that were given away by the bowler. And another here important statistic is this player dismissal ID, which gives you the information regarding which batsman was bowled or caught or like basically made out in which ball and by which bowler. So as you can see, you have a lot of information provided. Another one, for example, will be player database that holds from where we can match each player number to the player name and which country they're from. And then you have player match where you can keep track of whether which team he's a part of, each player is a part of, and which match they played in, and whether he's a keeper or a captain, or maybe in some cases both. And then you have this one here, season, where you get track of all the seasons and what were the statistics like orange cap, purple cap, and the series for each season. Then you have teams. So here again is an important one where you can keep track of, like earlier in all the previous tables teams were mentioned by the team ID, so here we can get to know like which team they represent. So without further ado, I'll go to the queries now. So I'll load up our first query 1. So here our objective was to get the leaderboard of the highest scoring players who are captains. So basically we are looking for players who are captains and then putting them in descending order of their runs scored, total runs scored. So here, as you can see, it's a pretty lengthy query with sub-queries in it, and I'll explain it with the data first. As you can see, after executing the query, you get this output here, which says like it keeps track of player ID, player name, and the runs they score, and as you can see it is in the decreasing order, and all of these are captains as well. So here also throughout this list of queries I've maintained this statistic here, player ID, for all the queries, because I wanted to keep a primary key for this project for all the queries, because if you were to work on any of these result tables, it would be useful because it can serve as a primary key, because all of them would have this player ID associated with it. So once again I go back to the code. So as you can see from the innermost select, you are checking so from ball by ball and player match tables, you are comparing the striker ID to the player ID, as you can see. So here you have player match, sorry about that. So here you have player match, and that you are comparing to striker ID. So basically you can get to know which team he is a part of, and you can get to know whether he's a captain, and also how much runs he scored from this statistic. So basically what you're doing here is you are taking the sum of all the scores, all the runs that he was able to score for all the overs that he faced, and so as you can see there are multiple sub queries here, and from the innermost one you're linking those two tables together, ball by ball and player match, and you're saying that the striker ID corresponds to the player ID in player match database, and you're also comparing checking whether he's a captain or not from this. And then when you get that kind of information, then you are taking the sum of all the runs he scored, and you're storing it as runs, you're storing the striker ID as player ID, and then when you further take it out to the next level, there you are grouping the striker ID and the runs together, like thereby giving you this common repository from which you can get this name of the player and their player ID, as well as the runs that we calculated before over here. So that's how you get that output. So moving on to the next query number 2. So this is the leaderboard of players who have hit the most number of sixes. So here what you're doing is that you're combining the tables ball by ball and player, and then you're basically saying that combining this table and the common player ID. So basically you're saying that striker ID in ball by ball is the same as the player number in player table, and then when that scored run is equal to 6, you make count of it. So basically with this, subject to this condition, you'll get a count of how many sixes were scored by that player, and from that player database you also get his name as well. So if I were to run this, I would get this. There you have this player ID, batsman name, and the number of sixes he scored. Now moving on to the next query number 3. Here we have a leaderboard of players who have been man of the match most number of times. So here again you're combining the tables player and matches. Here on the condition that the player number is equal to the man of the match ID. So basically you're saying that you want to find the man of the match information from matches and equate it to this player number. So from the man of the matches from the match database, you get who was the man of the match ID, and that ID you're equating it to this one here, player number here, and corresponding player name you can get. So that's what we are doing over there. And so basically we count the number of matches in which this player was a man of the match, and then we are storing it as man of the match count. And also you get player name from the player table as well as the player ID. So if we were to run this one, you get this sort of an information where you get a player name with the highest number of man of the match counts, and that too in the descending order you'll get. Now on to the next query. So here the objective is to find the leaderboard of batsmen in decreasing order of batting average. And once again here I found out the minimum condition that 10 outs, at least 10 outs should be there for this person in order for him to qualify, because otherwise there will be this kind of outlying conditions where one person would have participated in only one match and maybe he would have scored a 6 over in that, and all of a sudden he will have a very high batting average. So in order to avoid those sort of conditions, we make sure that he has played a decent number of matches to take this statistic. And once again, batting average is given by the total number of runs he scored by the total number of times he got out. So the way you calculate this is, first you have these kind of two subqueries where from which you count the number of times he was out. So from ball by ball table, you check the player dismissal ID, and for example here you have 3. So you count the number of times that player has gotten out through that, and there you get the outs value. Then you are basically linking it to the player number, and also meanwhile you also have to find out the total number of runs that he scored. So for this, since you can't use both searches in the same query, you have to have an independent subquery for that as well. So here you're finding out the runs by taking the sum of the batsman scored, from the ball by ball table. So then with these two values from the main query, you will be able to find out the batting average as runs divided by outs. So if I were to run this, one, I will get the output as the batsman, the total number of runs he scored, the total number of times he was out, and thereby getting the batting average. So here you can see Chris Gayle was the highest, and it is in the descending order as well, descending order of batting average. So moving on to the next one, query number 5. Here you have a leaderboard of bowlers who have conceded the least number of boundaries in death overs. So death overs are the overs between 16 to 20. So here you are combining these two tables, player and ball by ball, and you're basically saying that the player number in player table is the same as the bowler ID from ball by ball table. So basically you're matching the bowlers. in order to get their name. So here, if the batsman had scored a 6 or a 4, we'll keep count of that. So once you get the count of all the boundaries that the batsman scored against this bowler, you store it as boundaries conceded. And then you also display the bowler name as well as his ID. So if I was to run this program, you would get this way. Here, this is the ascending order. So basically you're looking at least number of boundaries conceded, and then you get this table. Also, one thing to keep in mind is that I've also given this condition here where you say it's over the 15th over, basically saying that it's between overs 16 and 20, the death overs. Now moving on to the next query number 6. Here you have the same or similar kind of a query where you find out the bowlers who have conceded least number of boundaries in power play overs, which is like 1 to 6. Pardon, 1 to 6. Okay, so here then again you find out the total number of boundaries that were conceded, and you give the condition that this over is less than 7. So 1 to 6 basically. So here once you execute it, once again you get the list of data with the bowler and the boundaries you consider in ascending order. Now moving on to the next one. So query number 7 gives us the leaderboard. Sorry for that. Query number 7 gives us the leaderboard of bowlers with the highest number of dot balls. So dot balls are the balls in which the batsman hasn't scored anything. So here, a similar kind of condition, you count the number of balls in which the batsman scored 0. Once again combining this thing, ball by ball and player table. So with that, once you execute it, you get the bowler, his player ID, as well as the dot balls he had. And this once again is in descending order, saying, so basically here Praveen Kumar has the highest number of dot balls, and then it is in the decreasing order, so it's a leaderboard. So you open next query number 8, and here you have a leaderboard of teams with most number of wins in each season. So this is a fairly simple query. Here we take the data from tables, matches and teams, and then you are able to equate team ID to match winner ID. Here team ID is from team table and match ID, as you can see, is from matches table. You will be able to find out the team that won. So basically if you count that, you'll be able to get the matches won for each team. So once I execute this, you get for each team what are the matches won. And once again, the team name you can get from the team table. Now to open query 9. So query 9 gives you the leaderboard of batsmen who have scored the highest in death overs. So once again, death overs is like 16 to 20. And what you do is you join these two tables, player and player by ball. You see that player number here in player table is the same as striker from ball by ball. So for you go to ball by ball, you'll be able to get this statistic, batsman score and the striker ID, and you're seeing that this striker ID is the same as this one, player number here. So there you'll get the batsman's name as well. So if I go back here, you'll be able to see that for overs greater than 15, meaning 16 to 20, you get the count of, sorry about that, it is supposed to be some. Okay, so here once I execute it, you get the total number of total runs scored for each player. And yeah, moving on to the next one. It's as simple as that. Let me save the result, and now I'm gonna open query number 10, and here you have a leaderboard of batsmen who have scored the highest in power play overs. So the same procedure, but here you're changing the condition to overs less than 7, basically 1 to 6. Now if you execute it, you get a list of players and the runs they scored, but here being in the power play overs. Now opening up query number 11. Here our objective is to find the leaderboard of batsmen with the highest number of runs scored in batsman versus bowler matchups. So here if you consider all kinds of matchups between a batsman and a bowler, you're finding out which batsman had the best score, meaning highest score in individual matchups. Also you have set this condition where the minimum number of balls faced should be at least 60, meaning 10 overs, because once again you have to make sure that you remove all kind of anomalies. So here what you're doing is basically you're going in, you have subqueries in order to do this. So basically you're looking at ball player and ball by ball, and from this you're saying that the player number here in player table is the same as the striker in ball by ball, and then you're finding out the total runs scored by this player, and then you're also taking out his name as batsman and also the bowler ID, finding out his bowler ID as well. So with that you're also grouping the bowler ID with the player name. Basically you're linking the bowler ID with his player name. So with this the net effect would be able to get the batsman with his for any specific batsman with his name, you'll be able to find out his run scored, the total number of balls he faced, and then against which bowler he was facing against. Also given the condition that he has at least faced 60 balls. So if I run this, you get something like this, where you have batsman, the run score, the bowler, and the number of balls this batsman faced of that ball. So it's in the decreasing order of total runs scored in this individual matchups. And that's it for this query. So if we go to query number 12, sorry about the interruptions. For query number 12, you have a leaderboard of bowlers with the best economy rate in batsman versus bowler matchup. So similar to the previous case, here what you're doing is here you're finding out the economy for each bowler. So once again you find out the total number of runs that the batsman scores through this, plus the total number of extra runs the bowler concedes, and with the sum of that you get the total number of runs conceded by the bowler, and then you also with the count of number of balls you get the total number of balls thrown by the bowler as well in this matchup. So by doing this, so this was taken from the subquery, and this condition was also given where it should be like greater than, I mean, the bowler should have at least thrown 10 overs against this batsman. And now with this you get the number of overs bowled, because that is basically the number of balls thrown by sits. Then you also have runs conceded from the subquery, same as bowler ID, batsman, etc. So with this, since you can't order the query both based on runs conceded and at the same time do this here where you equate it with the player number as well as order by economy rate, since all of this formatting is not, or sorting is not possible at a single step. You have to put all of this under another query, parent query over here. So basically you borrow all these values you found out over here and take it to the next level, and so we are left with the bowler, the number of balls overs he bowled, the batsman, the runs conceded by the bowler, as well as the economy rate. So if I run this, should be able to get something like this, where you have the bowler, the overs he bowled, the batsman, against whom he was bowling, the runs conceded by him, and the economy rate. Now that's it for this query. I'll be opening up the next 13th one. So here you have a leaderboard of players who were captains for the most number of matches, where they were captain for at least one match. So the reason why I added this part is because in this leaderboard I don't want players who are not captains at all. So they should have been captain at least for one match. So that's a condition. So here here again you need a subquery from which you found out all the matches in which this guy was a captain, and you mark it as number of matches. So this is the condition from which you find out whether this guy is a captain or not from player match table, and then you group it by the player ID. So for all these, so basically what that does is like you take out a list of players and find out all the matches in which this guy was a captain, and with that you calculate these values, which you take it up to the parent query, where you display the player ID, his name, the number of matches that he was a captain in. So if you were to run this, you get player ID, name of captain, and the number of matches in which he is a captain. Once again, since it's a leaderboard, I put this in decreasing order. So basically here you can see Dhoni was the one who has been the captain for the biggest number of, the most number of matches. Sorry. So once again, that's it for this query, and here we open up the 14th. So here our objective is to get the leaderboard of teams with the highest average run margin for each season. So the average run margin is like for each, let me go here to matches, I guess. So here, as you can see, you have this statistic where you see, first of all, from this table you get the team name, his opponent, which season it was, and who won the match, and by how much they won. So basically from these values you'll be able to find out whether our team of consideration, whether they won the match, and if they did, by how much they won. That's what we find out from this subquery over here, and from this subquery you find out how many matches they lost and by how much. So that is the loss margin here. So basically from this one, what you're doing is you're from matches you're finding out which matches that equate the team to the match winner ID. So from that you get, if you keep count of that, you get the number of matches won, and if you sum up their margin, you get the victory margin. So that's what you get from this. So here I have stored it as team 1 and season 1, here team 2 and season 2. This is to avoid confusion when the parent query picks up the information, because if both of their names were season and team here, it will be confusing for the parent query when it inherits all this information. So for this subquery, here you are given the condition where the team ID is not the match winner ID, so basically our team didn't win, and also you have to make sure that the team in consideration is either the team ID here, team 1 or team 2, basically the team or opponent team in this what is it, match table. So here you have match winner ID, and so basically it has to be one of these two, either it should be here or here. Then you find out the matches lost and by how much they lost. So once you have all this data, you go up to the parent query where you find out total number of matches, which is like the matches won plus the matches lost. Then you find the run margin, which is the victory margin, total victory margin minus total loss margin, and then when you divide this run margin by total matches, which is what we are doing in this step, you get average run margin. So if I were to run this query, you'll get this sort of a big table where you have the season and the team, the total number of matches that each team played, the matches they won, the matches they lost, and the run margin, by the overall run margin that they had compared to other teams, or compared to a neutral case where they lost and won by the same amount. So here is a margin, run margin. So overall they had plus 217, and the average run margin is given by this run margin divided by total number of matches. And that's it for this query. So for our final query, query number 15, we are finding out the leaderboard of batsmen with the highest strike rate, having at least faced 60 balls. Here again I've added this condition to avoid anomalies. So here you're taking these two tables, player and ball by ball. You're saying that the striker ID here is same as the player number over here. So basically combining these two tables, you get these information like the total runs scored, balls faced. Then if you divide this by this, basically runs scored by balls faced, into 100, you get strike rate. And now all this information like player ID, batsman, runs scored, balls faced, and strike rate is available, and you have already grouped it on the basis of the player ID or the striker ID here. And now we have to put this as a subquery, because you also have to put this condition over here and also give a sort based on the strike rate. So you need an external query for that, which is why you also inherit all this information, player ID, batsman, runs scored, balls faced, and strike rate, to get our desired output, which once I execute we'll have here with player ID, batsman, runs scored, balls faced, and strike rate here again. So that's what you have here. So I think I have, that's it. And thank you for listening.